So what is the energy? If you need energy to move a mass, that's energy usually is the work done on a body, and work done is the transfer of energy from one form to another. So if you required energy to move a mass m through delta v, it means that you are doing work done on the object. And how do we define the work done? We define the work done, W, the work done on the object. This is the first portion. W, work done on the object, is F multiplied by the distance it has been moved, F multiplied by delta R. Okay? And is with negative sign F dot delta R, because when you're pushing an object, when you move an object across a potential difference, so you are coming the potential difference, and there is a cosine of minus 180 so plus 180, which gives you a negative sign. So work done is equal to minus F dot F delta R, because the work, or you can simply say that the negative sign indicates that the work done on the object that has been moved in gravitational field, the work has been stored in that object. Okay, and when you release that object, that work will again be converted into kinetic energy. So the negative sign is the indication that this pen is here and I'm bringing it up. So the work I'm doing on it is against the gravitational field, and it is being stored inside the pen. And when I will release it, this work in the form of potential energy will be converted into kinetic energy, and the pen will fall down. So the negative sign is here, and this is our equation number 1, which is really simple. We derived it really simply from a basic principle that work is W is equal to minus F delta R. Thus the equation of gravitational field strength can we use the equation of gravitational field strength to reach the same result? Now let's define. Gravitational field strength is the negative gradient of gravitational potential. Okay, but we also know that gravitational field strength is force per unit mass. Let's call it A and call it B, and compare these two, because both are gravitational field strength. So minus delta V divided by delta R is equal to F divided by M. Okay, and what do we get from here? We get M into delta V divided by delta R is equal to F, or M minus M delta V is equal to F into delta R. And this M delta V minus M delta V is the work done on the object. So F delta R is equal to work done. Or sorry, we can say from here minus M delta V is equal to work done. So we are using this equation to replace this by work done. So we use the value of G, we use the equation of G, and we reach the same result as we define the energy from our work equation. The work done or energy is equal to minus M delta V. So that's how we can use the definition of G, gravitational field strength, to derive the work done equation. Okay, and this is a really important equation then that we can use to find the work done on an object.